here to talk about Warno. Essentially, I'm a radar engineer, so we have a lot of radar spread throughout the world, and kind of monitoring is a problem. Work for a group called ARM. It's a multi-lab group that does remote sensing instrumentation for things like climate change and weather. The tagline is the world's premier ground-based observation facility advancing atmospheric and climate research. It was founded in 1989. Kind of the cool thing is we have 3 fixed sites and 3 mobile sites. So we have sites that basically go around the world. If you can see it on the map, that's some of the places we've been recently. So it's pretty diverse in terms of like where we put these things. We've done about 580 field campaigns, right? So quite a few. We have 130 different types of instruments. We have an aerial facility, so an airplane that's instrumented, about 10,000 data streams. Are we back to this? Just to keep you awake. There's what? Well, see how well this goes for now. We'll go with HDMI. I'm guessing this is going to be endemic, so I'll just kind of talk through it even what it is. So kind of the cool thing is we essentially have the largest research radar network in the world. We have 33 radars spread throughout the US. It's kind of some of the places I showed. Kind of what makes us unique is that we have a lot of radars. So I'll just talk through so this comes back. They're all different. It's kind of the annoying thing. Gives you a bunch of different features and functionalities that you can do. We have frequencies from C-band through W-band, so from 5 to 95 gigahertz. They're from different vendors. They have different interfaces and everything. And they go into some very remote locations and some very harsh locations at that. So these are at Aliktok Point. And it's the North Slope of Alaska, so it's not exactly a hospitable environment. The picture on the upper right was actually, I think, -40 when I was there and windy. We're working outside on a platform. There's also no sunlight because it's December in the North Slope of Alaska. If you see a little bit of blurriness on the picture, it's because my camera started to freeze while we were trying to take the picture. So it's not a good environment to go out and doing a lot of these measurements. We kind of want to instrument stuff to let us do this. And we also go to just places that other people tend not to. So if you've ever seen the 30 Days of Night movie where there's ghouls or vampires attacking a town, a little bit after that came out, we decided we should put a radar there. Someone doesn't like our engineers, apparently. Polar bears are a big thing up there, so polar bears tend to come along and try and eat scientists and engineers. And then we put them on tropical islands, which is usually a little more fun. On the right here, we have like a land crab that actually didn't go down the water. It stays up in the mountains. One of the big problems we have, though, is, like I said, we have 33 radars. We have 4 radar engineers. So traditionally, you're running each radar with 4 to 5 engineers in most programs. Ours is kind of inverted that way, right? And so we really don't have time to even look at all of these. So we need kind of smart systems that kind of warn us and notify us, bring everything to kind of a common area, and just kind of make our life easier. If we were to actually look at these, it'd be 11.6 hours per day per engineer, counting weekends. So that's just to look at them, not even to fix anything. So obviously this is not a tractable problem. So I was brought in for a couple things, but one of them was Warno. Essentially, it's a cross-platform system to capture metadata and operation about how the radar is working. Provides kind of a central monitoring location, so we're not going to each different radar page and SSHing into different computer systems every day. It tracks and stores both the component performance and the radar performance. Does things like analytics, and we're putting in warn on alarm. It's meant to support engineer troubleshooting and diagnostics, provide visualizations, things like that. Just kind of make our life a lot easier in general. We will give it a second. Cool. So roughly speaking, it runs inside a Vagrant VM. It's a series of kind of internal web servers that are running in a plugin framework. It's split into kind of 4 main pieces. So we have the agent, which is kind of the information gathering piece, and it's kind of what changes for each radar. And then from that, we have the event manager, we have a user portal, and then it's all backed by databases. The nice thing is these are all homogeneous across the network. So we're going to end up deploying these at multiple radars, and the idea is we don't want to have 33 versions of the software, right? And we need it to work both on-site and off-site, and on-site may not have access back to the central server. Seems to be flashing in and out, usually at the right time at least. Cool, so the general idea is Warno's distributed. We have a central installation that runs and kind of collects data from all the different radars, but then also a full installation Warno goes at each individual radar. right? The reasoning being that technicians are on site in places like the North Slope of Alaska, over a very poor internet connection. We don't want them sending all the data up to a central server and then pulling all of it back down, right? It doesn't make sense. We want everything stored on site. Plus, we tend to put radars in things like ships where you may not actually have internet. So you want to be able to store it locally until you connect back to the internet, and then you can push it all back up. So I'm going to kind of go through kind of the architecture a little bit, and I'll do some live demos if we can actually keep me connected to the projector. Kind of one of the things that we thought was really cool is we actually kind of built a whole plugin infrastructure around it. So instead of having to code in all the functionality inside the core Warno itself, you could just put these plugins that are dynamically discovered at runtime. We had to abuse importlib pretty badly to make this actually happen, because it turns out, at runtime, plugging things into Python is not the simplest. The nice thing, though, is the plugin design themselves are really simple. We do all the work in the back end. You essentially just have to implement kind of a register and a run method that gives some metadata about what you're going to be returning. And then we handle things like the message passing. We give you a queue that you just put your data in JSON format on. And we handle registering to the database, making sure the multiple databases stay in sync, things like that. Each of the plugins runs in multiprocessing, so we could keep them kind of isolated, take care of parallelism, stuff like that. And just puts it down anyways, I can pull up the terminal. Yeah. So here's the implementation of a simple plugin. I don't know if you can actually read the text. I'll make it a little bigger. And so this is a full plugin that will actually do system status and health for us in terms of taking things like CPU, percent usage, and it's just mostly an example plugin. But all you essentially do is when you initialize it, you're calling up to initialize the parent object. Then you're just adding things like, what event code you want it to be called, what instruments, what's the plugin description. You get a configuration object back that'll actually tell you a lot of information that you can store in there as well if you need configuration to do plugin specific things. And then you have a run method that basically just captures data and needs to put things on a queue. And then at the end, it just says process the control queue and process the message queue. And we handle passing it up through all the different systems, tagging it and everything. So right above the plugins is the agent. The idea is that the agent's just in charge of running all the different plugins, right? It handles the registering of them, handling config data. It plays a go-between with it in the event manager. The nice thing is the agent itself is actually identical, and so from the agent and above, everything for all the distributed systems, for any radar, for any of the instrumentation we do, and we use this on other instruments and radars too, now we're starting to look into. It's completely homogeneous, same code base. We just get deployed everywhere. Any difference between the instruments themselves are just handled in config files. We have little YAML files that make it pretty easy to configure what you're doing. And then each agent also has a dashboard, so you have control of each plugin. You can start, stop them, reload them, things like that. One level up from the agent is the event manager, and it kind of plays the role of the traffic cop in the system. So you have the agent passing back all these data packets saying, here's the kind of information I'm gathering. This gets it to the right place. So we have kind of multiple databases that are going on that I'll go into. And this makes sure it gets into each of the databases as well as getting up to the central system. Right? So we have kind of a nested hierarchy on this. And then this can also run multiple agents, so that if you want to, say, do multiple systems on site with just one Warno installation, you can as well. And so where people really are going to start interacting this, though, is the user portal. So this is a website that sits on the front end. It's fed by Flask that does real-time visualization. You can get real-time status updates. Our front radar page for the program, we actually feed off of this now as well, so people can get real-time status on logging and things like that. It's really meant to be kind of the central access point into Warno for anyone but a developer. So I'll actually hopefully do this live if this doesn't start flickering too much. If not, I have screenshots for everything. But so this is essentially what the front page of Warno looks like. Forgive me for the fact that it's kind of ugly. We let engineers design CSS stuff, and we are horrible at it. Yeah. So the cool thing is this is kind of what people see when they first come here. And so we have the status of all of our different radars. We have ones that we've integrated into Warno, then we also have ones that are either too remote for Warno or that we haven't gotten to finish writing the integrations for yet. When you mouse over things, you can click on an instrument, see a little pop-up with the status. These are actually markdown, so you can embed things like images and video when you're doing the logs. These are actually maintained by someone every week so that we go through and actually hand do a nice detailed log with status. We have a lot of other little things across the top. One of the neater ones is You can go to, like, say, an individual site, and so you can define multiple geographic areas. We're going to have instruments clustered, right? And so each of these are kind of tied through one connection. Each of the little circles you see in here are actually the coverage area of the instruments. The colors of the icons are their actual status. We use a WMS server to pull in things like Nexrad, so we can actually in real time display information from other networks. So we're not really meaning this to go through all of our data. We want it more for kind of context about what's going on in the radars. Are they breaking? Are they running? And it's really helpful to be able to see other instrumentation when you're doing this, so you're not working in a vacuum. You can S these. We also have things like visible, which is a little less exciting. And we have this coverage for kind of pretty wide place. We do two of the Go servers, Nexrad, and then we pull in EU Metsat. So I can get this to zoom out. We can pull in, say, infrared over Europe as well. Right, and so the idea is for everywhere we go, we try and find a new tiling server so that we can, kind of steal data and apply it here without having to do a bunch of work. And it's nice, you just add a couple lines of code and it displays all of this. So kind of the core interface for this, though, being able to see the sites is nice, but we've said we want to use this for things like analytics and to actually get a sense of the state of health of the radar. And so the dashboard kind of is the main place people go. And like its name sounds, you can actually put together little dashboards. And the idea is picture them as a bunch of little like widgets or customizable cards that each have a visualization type. So let's just pick something. Yep. Let's do. And so kind of one of the nice things about this, is there's different time ranges you can do, and cool, decides to break right now, but I guess that's how it goes. So there's a lot of different visualizations that we support, and then each of these can be updated in real time. So as a new sample comes in, and we have this set to go off every minute, which was kind of a good timing for us, this graph will actually start to update. You can switch it around to just be like a sliding window. So let's say we only want to display the last hour of data, for instance. And so this actually pulls from two different places. The Flask user portal that we have set up has both a PostgreSQL database that does all of this and has hundreds of millions of entries at this point, which can be a little slow when you want to do a lot of data, especially across the network. We also have a Redis caching server that sits in front, and we store about 2 weeks of data. We figure most people aren't going to care about historical data. Most users are going to come here to see what's going on with the network right now. And so the nice thing about Redis is it makes it very fast to pull all this in. It's a NoSQL database for those of you that don't know. And it's just got a little bit less complexity. Each of these cards can be flipped around, and they have different configurations on the back. We have a whole JavaScript widget manager interface that kind of encapsulates all these, and that way we can make sure the data gets just called once. But we have a lot of different visualization types we've slowly been adding in. You can do things like adding in histograms, and let's do this. Temp. And then each of these are kind of a little card that can be added or removed. You can change the sizes of them, make them nest in a little tighter. Let's add another dual histogram. So the idea is you want to be able to compare multiple quantities to see if things are, say, out of spec or if there's a correlation between different things, so that if something's breaking often, you know where it's breaking, you can say what's most likely causing this. Right? And so for these, we generate the entire contour, the distribution plots, the marginals on the side, things like that. These are all driven through Plotly. They're interactive, kind of all the stuff you'd expect from kind of a modern day visualization. The line charts are digraphs. So we have a couple different visualization libraries in here, whichever we thought worked best. The nice thing is for digraphs, you get this little mini map down here that kind of shows you the state of your plots. You can zoom around, things like that. So we've written a whole interface that basically makes it easy to encapsulate widgets from different libraries so that all the data control goes through a central access point. Let's go back to here. So some of the other ones we've done, and I'll just show them on here instead of keep clicking around. So we've done a lot of things on status plots, and we have real-time gauges. And kind of one of the cool things that you can do with this that I didn't show is once you finish making that dashboard, you can actually save it. So it saves the state of all the layouts, what's being displayed, what all your options were. And then you can basically share that with other people. You can reload at any given time. So you can figure out, let's say I know I always want to log in and see all the different temperatures, the different components. You can preset that dashboard up, and then anytime you come back, if you close your window, just reload everything. And then kind of one of the things that's really nice that we can do with this is we support like rolling averages internally on this. The idea is if you're used to looking at a lot of time series data that's coarsely sampled, it can be very noisy. And so this allows you to essentially supply a rolling window that is things like means. One of the things that we're now implementing, that should be coming out pretty soon hopefully, is the ability to then do kind of second order plugins. So all of our plugins right now are for information gathering. They go out to a radar, an instrument, or a file, and pull data into the database. The idea is to do plugins now that operate on the data you've already gathered and trigger actions. So things like sending an email for a warning, toggling a status, turning a radar off if we needed to. Right? So the idea is you now start to imbue actual actions into this. So we try to make this as open as possible, and so we actually have a REST API that anything that we pull onto that web page, you can get access to the API with. The nice thing is it's kind of self-documented, so anytime you go to a point and it refers to something else, it gives you the URL for it as well. I'll skip some of that. So one of the nice things also is there's users. You don't want to give, we say we do logging in this, and you don't want to give your users the ability to change the instrument status. People log in to view this, not to toggle it and change it necessarily. And so you can give basically different security levels and say this one can do a log, this one can change a site, and so on. Short run out of time. So it's not the easiest thing to work with in all honesty. Everything's in a VM and it's distributed. So we decided we're lazy. So everything's customizable and orchestrated through Fabric. It's just a bunch of remote commands you can run, and this handles handing them out kind of nicely so you don't have to log into different systems. And then one of the nice things you can do is you can tie this into things like Jupyter as well, right? So because that REST API is there, we have it set up so that you can request certain keys and time periods, pass it through pandas, and then do automated plotting, right? So if you want to do more detailed analysis, you're not limited to just the visualizations we give you. You can pull it onto your own system, take the data, and run with it. And so this doesn't kick out again. Here's an example, and it's really easy. It's just an API access point that you're getting. You pass it through JSON reader, through pandas. Then you can do things like plotting in the browser, generate, say, CDFs or other visualization types that you have. So this is open source. It's free for everyone to download and use. It's a BSD license. You can actually go play with it there. It's not the easiest thing to get started with, in all honesty. It's got a lot of moving parts behind the scenes. We do our best to try and clean it up to make it generalizable as much as we can. And then I like to put, cool, this is just like dancing forward. So one of the things I like to do is put these slides that basically tell you what different technologies we're using instead of calling them out as they use each one. And this is a partial list. The list seems to be growing every day. But this will kind of tell you a little more about what we're actually doing. I think I'm limited, so. As far as things we're trying to add, we're trying to really generalize it for the community. The idea is we'd like for other people with networks to start uptaking this, or even if you just have one instrument, use it to kind of see what's going on. So most of it revolves around things like cleaning up documentation, generalizing it, making it a little more lightweight, because right now the VM image for this can be about 11 to 12 gigabytes, because there's a lot of software packed into there. But I'll just dance through so I can have questions.
Okay, we have some time for questions. Does anyone have? Yeah.
So you said that you had to do some import lib hacks to do the plugins. Mm-hmm. Have you considered using the setup tools entry points? I've done some plugin work myself that really simplified things, since you can just get an iterator of all the entry points and load them.
So we looked up for a while trying to figure out a good way of doing this. There were a couple custom plugin implementations that people had. And just none of them seem to quite work out for different reasons. But I'll talk to this after to see what you can do. Cool.
Other questions?
Thank you. I just had a question. So this application you guys made for radar stuff specifically. I was wondering how hard it would be to, say, tweak it a little bit to, maybe monitor stuff in a building, like electricity usage or something like that. So different kinds of signals, basically.
So technically, this doesn't actually know what a radar is. Since we only have radars, that's what all the examples are for. But the information gathering plugins, they're just generic Python plugins. And then from then on, nothing's actually radar specific. It's all just general visualizations.
Thank you.
Other questions? All right, let's thank our speaker again.